All right, so what we're going to do now is practice predicting when a precipitation reaction takes place. And again, precipitation is double replacement. Now, I used to do this demonstration in class, but I didn't have that video, so I went ahead and used that other video to introduce the idea of double replacement. But this is a double replacement precipitation reaction, and we're going to look at how you predict those. Now, the first step is still the same as what we did before. We wrote out the reactants as ions, right? That's this first step. Second step is we predict the products based on the ion charges, right? So that again is what we did in that earlier example. And then finally what we do is we look at the solubility rules to see if any of the products are solid. That's the way we know a reaction is going to take place. Remember, we did it the other way. We took two solutions together and we saw the solid form, right? Then we knew that a reaction had taken place. But with precipitation reactions, when you're not actually doing them, you look at the solubility rules to try to find a product that is solid. Okay, so if a reaction occurs if a solid is formed. Now, the reason this happens, kind of a more sort of philosophical, theoretical level, is because when the solid forms, it's very stable and it helps to make the reaction go. Okay, so let's practice on these two reactants. Okay, and you don't have to write the formulas out. They're already done for you. And if that's the case, you just assume they're correct at this point. And what we're going to do is write this out as ions. So the first step is write out the ions. And the ions are going to be Ca2 plus and 2 nitrates like this. And then it's going to be 2 Na pluses and 1 CO3 2 minus like this. Now what we do is we use double replacement, right? We're going to take the calcium and put it with the carbonate and the sodium and put it with the nitrate, and those will give us our new products. Now which one you write first doesn't matter, okay? But I'm going to start with the calcium since it was first in the whole list. And I'm going to go like this. And again, the reason, that's what I started with, sorry. I'm going to just write it like this, CO3 like that. And the reason I'm doing it like that is because there's a 2 plus here and a 2 minus here, so I can just put them together, right? The charges are balanced. And then I'm going to have Na plus and with NO3 minus, and those balance as well. And then what I have to do is look at the solubility rules to figure out whether or not a reaction takes place. And for a reaction to take place, one of the products has to be a solid. Now, I'm going to sort of cheat here. I know that's a group 1, so that's aqueous already. So I'm just going to write that. It's important, actually, you try to memorize that one because it saves you a lot of time. Now, calcium carbonate, I got to go up to carbonate, right? So I'm going to go back to these solubility rules like this. And I'm actually going to clean this up. And I'm going to take a quick snapshot of it so I can just sort of skip back to it later. Alright, there we go. Let me blow that up just a little bit. There we go. So now, I have carbonate, right? Generally insoluble, and calcium's not an exception. So what that means is that when I go back to here, that calcium carbonate will be a solid. So I can go back to here and say that this will be a solid because the carbonates are generally insoluble. Calcium's not an exception. Now, nitrates are also always aqueous. Okay, so what I can do is I can also put in the states for here. So that's one of the things I need to do as well because it says states of reactants and products. This is aqueous, and this is also aqueous because of sodium. Okay, now, does a reaction take place? And the answer is yes, because I have calcium carbonate being formed. All right, we're going to predict, right, the products and use solubility rules to do that. And we're going to do this next one, and this one's a little trickier because the formulas weren't given for you. So I'm going to write iron 3, oh sorry, start with an I, Fe 3 plus, and Cl minus. Now you notice I didn't worry about the formula for iron chloride yet. I'm just writing the ions down, and aluminum and sulfate. So aluminum is one of those fixed charge ones, and sulfate is SO4 2 minus. Now, from those ions, now that I've written them out, I can write both the reactants and the products. Okay, so I'll write the reactants out and the products out. So it's Fe Cl3 plus Al2SO4 3, like that. Now my products are going to be the iron going with the sulfate, so it's going to be Fe2SO4 3, like that. And then the aluminum goes with the chloride now, so it'll be AlCl3, like that. Now what I want to do is I want to go look up the states, and so I'll pop back like this. Right? Oh, actually, I'll just switch over to my other slide now that I've created it. And sulfates are generally soluble, and there are no exceptions in here listed on our reaction. Right? So that means iron sulfate will be aqueous, and aluminum chloride will go back to chloride. Right? And we'll find chloride up here, and silver, mercury, or lead are insoluble, so chlorides are also soluble. That's what I'm finding out. And so this will be aqueous. Now, at this point here, when I know both of the products are aqueous, I can say that there's no reaction. Now, if you want to, you can go through the exercise of balancing this. I could do it for you really quick, but you might want to write it out and try balancing it yourself. But that's the balanced equation. Okay. One more example, and we're going to do sodium hydroxide and iron 3 chloride. And what I want you to do is write the reactants, or write the ions, write the reactants and the products from the ions, and then we'll stop and try to predict if a reaction takes place. I'll pause the video here and you can do that. Okay, so these are the reactants and products, and if you look, this is group 1 for sodium, so this is aqueous. The sodium hydroxide will be aqueous because of sodium. And then all that we're left with is the chloride and the hydroxide of iron. So we'll go to our solubility rules. And what we find is that the chlorides are generally soluble. Iron's not an exception, so we know that one's aqueous. And let's see. Hydroxides, here we go, are generally insoluble, so iron's not an exception. So we'll go back to here, and what we find is that this is a solid and that this one is aqueous, like that.